Okay, this is going to be a catch-up lesson. We're going to go over, first of all, what indefinite integrals are, and that's a review of what we've done in class, and then we'll move forward into the newer topics and the completely new topics as we work through these little video lessons. So for indefinite integrals, remember that an integral is like the reverse process of differentiation. And as one student put it, integration is like primitivization, which isn't actually a thing in maths, but I knew exactly what she meant. It means the reverse of differentiation. First of all, what we need to have is a basic template for what we do with finding an integral. So we have the basic structure that given a function, if I integrate this function with respect to x, if I integrate this function, this is the function with respect to x, then what we'll end up with is another function which is in some way related to the original function, but there's also the possibility of a constant. So we put in c, and that constant arises because it's an indefinite integral. We've got a general template for what it is that we'll have after the process of integration. We'll find out that later on, if we have some boundaries on our integration, then actually that constant will be unnecessary and it disappears. It will cancel itself out. All right, making that look something a little bit more workable, that's quite esoteric and very mathematical in its nature, but making that look like something more workable, it means that if I have the integration, if I integrate x to the power of n with respect to x, if I integrate x to the power of n with respect to x, then what I'll end up with is x to the power of n plus 1. So whatever the indice was, we add 1 to the indice. The whole expression will be divided by whatever the new power was for integration, and then plus this constant. So that is really the key thing that we're going to be looking at in this whole process. Now what I want to do is work through some examples out of the textbook. I think the exercise is exercise 3.4, and I'll just use some of the questions from exercise 3.4 to help us see how this all actually works in actual practice. Alright, so question 1, we've got this. We need to integrate x squared dx. Okay, it's an indefinite integral. You can tell it's an indefinite integral because there's no boundaries, there's no limits to the integration, no boundaries of integration. When we do that and we follow this pattern, well, the indice in this case is 2, so what we have to do is go x to the power of 2 plus 1, then all over 2 plus 1. So we'll end up with x to the power of 2 plus 1, which is 3, all over 3, plus c, and we must have that plus c. If in an exam you have an indefinite integral and you don't include this plus c, you'll get the answer incorrect. You won't get the marks, you'll lose marks. So it's absolutely imperative for a primitive or an indefinite integral to have the plus c. Question 1, easy peasy. Question 3, let's have a look at question 3. A tiny little more complex. 2x to the power of 4 dx. Okay, now with this, something that can be helpful when integrating is that 2 is a constant multiplier, and it can be helpful to take that out the front of the integral sign, because all this will be doing is multiplying any result that we get by that constant 2. So let's take that out the front. So we'll have this 2 outside of the integral of x to the power of 4 dx, and now we just follow the same process that we had before. Following this template, it will be 2 outside of x to the power of 5 on 5 plus c. Now someone pointed out that shouldn't that plus c be inside the brackets here also, so that it can be multiplied by 2? And that is, in one sense, very correct. But if I multiply a constant by 2, I still only end up with a constant. So either way, any way you look at this, we're just going to end up with a constant. And we can just write that out separately to the expression that's in the brackets. Final answer would be 2x to the power of 5 on 5 plus c. Okay, question 3 done. Let's have a look at question 8. We'll skip ahead a few. We'll have a look at question 8 from the exercise. Question 8 is we need to find the indefinite integral of 2x plus 4 with respect to x. Finding this indefinite integral. Now, in this case, this is a constant additive, but we can't take that out the front of the integration sign because that will actually end up being a part of the x function that we'll end up with. So the next thing we'll end up with here would be, there will be no integral sign. We'll have 2x to the power of 1 plus 1, which is 2, all over 2, plus 4, and this was originally x to the power of 0, because x to the power of 0 is equal to 1. So this was 4 times x to the power of 0. Well, now 0 plus 1 means that the x, instead of not being there and easily being able to be seen, will actually have a 4 times x, and then we have our c. And of course that can be simplified a little bit by making it x squared plus 4x plus c. The 2's will cancel. Right, not so hard. Skipping ahead again, question 14. So for question 14, looks slightly more complex, but the process is really all the same. We have in brackets x to the power of 7 minus 3x to the power of 6 minus 9, all integrated with respect to x. So on the next line, we add 1 and put the whole thing here over 7 plus 1 is 8. So it'll be x to the power of 8 over 8 minus 3x, 6 plus 1 is 7. So that'll be x to the power of 7, and this will be over 7 minus 9. And the x now appears, but we need to include the constant. And really that's all you could do with that one. There's no real simplifying of that expression. Right, so question 14 done. So you can see that the lines are working. There's not a huge amount of working here. It's quite following this template. It's a very simple process. Question 18, jumping ahead again. We have something that is not difficult, but it brings a few points. I think that's x to the power of 8.